Well, hello, my name is Jezen. It's good to be here in Poland. Nice and warm outside. So I'm going to talk about scripting in Haskell. Like you asked everyone what language they do, how many Scala people here? How many Scala people are here? A few. And Haskell people? A couple, and then Clojure people. Who hasn't put their hand up? That's almost most of you. What do you do? I mean, lovely of you to be here, but what do you do, really? I don't want this to be too alien to you. But everyone's a programmer, right? Almost, just about. Everyone wants to be a programmer. Everyone's used a computer, right? Okay. Some participation there. So I'm going to philosophize a little bit, and then I'm going to show you a very simple Haskell script, and then I'll show you a more complicated one that I actually use in a project to steal people's contact information. So a bit about me. I run a small online business in Haskell. And I also have a day job. And in my day job, I get to just work on a product most of the time. But in my own business, there are so many tasks that don't involve just working on my product. You know, you have your main project, you have like a big code base, and every task you do is some small ticket in a system, like you hack on this bit of the framework or whatever. Actually, in my sort of business, because I want to make some money, there are so many small one-off tasks. I want to sort of answer some business question, or I want to migrate some data because I screwed it up the first time, so I got to fix it and make it better. And this only happens one time, right? So it's not worth putting together a big project to solve a one-off task. I just want to write a script. Now, normally you'd use something like Bash for scripting. Who here has written any Bash? Okay, now everyone's a programmer. That's cool. And I like Bash a lot. You know, a lot of people will say Bash is old and terrible, and they'll jump straight to Ruby or Python or something. But I think Bash is great. I think everyone should use it more. I use it a hell of a lot. I wrote an open source tool called Git Smart in Bash. Has anyone heard of Git Smart? Has anyone heard of Git? Okay. So everyone uses Git. There's a Ruby gem called Git Smart, which it aliases git log, so you have like a nicer logging format, so you can have a better overview of your history. And it also aliases git pull. So instead of doing a pull, it does a fetch origin and then a pull and then rebase. So it chooses the right thing to do. But to run Git Smart, you need to have Ruby. I don't like to have Ruby on my system because I don't want to be a Ruby person anymore. I'm a Haskell person now. We're a bit tribal in that sense. So I rewrote the whole thing in Bash because there are no dependencies, right? Everyone has Bash on their system. I don't want to have Ruby on my system to run this Git tool. I use Git for everything. It's also because with Ruby, anyone used Ruby here? No? A few? So you're in one Ruby project, you'll have one Ruby version. You switch to a different directory in your system, and you have a different Ruby version. So now your Git tool doesn't work in this other directory in your system, and that's so stupid. So I rewrote the thing in Bash with tests. It's fully tested, you know, TDD style, rigorous testing stuff. I don't recommend doing that. I think I took Bash way too far with this project. But that was a really nice exercise. But I do use Bash for a whole bunch of things up until the point where it starts to get painful. And that should probably be your threshold for anything that you do. Actually, I mean, we can talk about language features all day, and we all do all the time. We go to a programming conference, we fight about language features. But so much of our technological choices should come down to, is this saving me time? Is this saving other people time? Is it going to make me more money or less money? Or my boss more money or less money or whatever? And there comes a point with bash scripting where the task you're working on might get complex enough that you're fighting with like single quote, double quote, single quote, double quote, backslash, escaping quotes all the time.
Isn't this what bash is all about?
Oh yeah, if you're into that kind of thing. There was that book, 50 Shades of Bash. You read it? There wasn't. I should write it though, right? Bash is good depending on the scale, right? And that's like most technology things. But there comes a point where it's not good enough, so you want to move to something more sophisticated. Most people would go with, I think, Python, because Python is on everything, right? Just about every system, I think, comes bundled with Python. I don't think the same is true of Ruby. So Ruby is not something I would pick for a script, because then if I want to run it on somewhere else, then I have to install an interpreter, and that's like time and effort, and I don't want to think about this stuff. I want to like run my script and then go do something else. And then also, should do it off camera, I think. We can edit that out.
You are off camera.
Yeah. Oh, good.
In that place.
How about now?
In the middle.
So yeah, we know that bash is quite sort of dangerous and dynamic and stringly typed, right? If we want to move to something more sophisticated, I also don't think it makes much sense to go to another language that's also not giving you much sort of safety in the stuff that you write. If you're writing tests for your scripting tasks, that'd be dumb. I mean, I've done it, but it's dumb. I wouldn't bother. So usually now, and for the past year or so, as soon as a bash script gets too complicated, I end up writing the thing in Haskell with Stack. Stack is a Haskell build tool, and you'll see it. You should all just go and install it anyway, and you should all start writing this stuff in Haskell. If you don't do this by next week, then I'll find you. Or no, then I failed you in this talk. Maybe that's enough philosophizing. I don't want you all falling asleep. So I'm going to just like write a script on the fly. If I screw it up, I've got a pre-made one. I should grab a chair. Or I'm going to grab this chair. Is that okay?
I don't think so.
No. Thank you very much. Ladies and gentlemen, Lek. Don't want to sit on this microphone. I'm going to sit like Jay Leno at my machine. Okay, even though I have a pre-made one, I'm going to try and write it from scratch. And I'm going to do it slowly so you can all follow along. Make my screen nice and big. You can see that it's 3 degrees in Warsaw. I wrote that in Bash too. If you want it, it's online. I'm going to move the one I made earlier to here because I want to use the same name. And I'm going to create this new Haskell file called greet. And that's as in like make a greeting, right? It's like a hello world, but just a bit more. Can anyone read it yet? As in the stuff around that, if I type, can you read the text? Yeah?
Does it compile?
Yeah, depends on the language.
It seems like combinatory logic.
Well, it's not a function if you ask JavaScript.
It's not a number.
All right, so you know when you're writing a bash script, you start with the shebang. Like, you know, you have the same thing in Haskell. You have a shebang. I'm sort of still learning this keyboard. I used to use a Swedish keyboard. Now I'm using a English American one. I don't know. So I think the shebang is something like user bin env stack, and stack is the build tool that I mentioned for Haskell. Vim is highlighting this line in red, which probably means it's wrong, which is really good. Vim is really good because it'll tell you that your argument is invalid before Mache does.
So the question, do you install stacks through cabal or through some package?
Oh, really good question. So I'm going to show you my browser now, which hopefully there's nothing too embarrassing on there. No like PHP documentation or anything. So you should all go to the Haskell stack website, and you can usually just run this line and you will get stack. And it will download the script and then like run it. That's not a security problem, I promise.
But does it use some kind of exploits to log in as a super user?
Maybe, but if you see outside they've got those little camera protectors, just use that first and then this is fine. Okay, so that's how you get stack. And we're going to start writing this Haskell script with stack. You need the shebang, and you also need this other initial comment line, which I think there's a couple of ways of writing it. You can write it on one line, or you can write it on lots of lines. Sometimes when you have lots of packages for a script, you'll want to write it on lots of lines. Nice that we have options. So it looks something like stack script, maybe? And then we need the resolver. And a resolver is like a snapshot of package versions. I don't know exactly how to explain it, but you have different versions of the compiler, different versions of the resolver refer to different versions of the compiler. I'm going to pick one that I've used earlier, so I don't have to download the compiler, because that takes a while.
Can I have a short question?
Yes.
How does using black font on black background affect the safety?
I'm so sorry. I can see this just fine. So maybe the problem is with you. What can I do here? Background.
Switch off the light or something?
I fixed it! That was some successful vimming.
White letters on white background.
I did set the background to light, but it's still dark. I don't know, take it up with the Unix people.
It's fine.
You know, I don't want to sit and guess at this too much, so I'm just going to steal the one from earlier. So that is what we need to get going. And then, like with any program, we need some main function. Was that better? We should have done it before. Hindsight, huh? So we need some main function, like every program does need one. And pretty straightforward, that'll print hello. Right? If I say greet, try and run it. This shouldn't work actually, because just like a bash script, you need to make it executable first. Right? So permission denied. This is normal, same in every language. So I do a change mode with u plus, I'm not sure what u does, x, I think is executable, greet, and now, hello, it works. Ah, thank you, I'll be here all week. Okay, this doesn't have a type signature, this function. It can do. You can, and I would suggest that you do write in the type signatures just for your own sort of clarity of thought. But you don't need to, because the compiler can work it out for you. But we know that this is an I/O action that returns the empty sort of, or the nothing tuple, the unit, right? And this will have the same effect. I'm not sure if I said it before, but if you don't have the compiler, then stack will try downloading the compiler first, so that you have it. And there's also, it's worth mentioning that if you were to do scripting in bash, then it works on Linux systems, but it won't work on like a Windows system, right? I don't know who uses Windows, I certainly don't, but maybe someone has colleagues who does. And if you go with something like Haskell scripting, then it should work on everything. It should be cross-platform. So with that out of the way, let's make this more interesting and give it, say, a command line, because we're on the command line and that'll be good. So we're going to do some monady type thing. I'm going to get the arguments from the command line, and the name of that function I think is getargs. And whoops, I got the wrong way around. Say name is getargs. So okay. So to get the name value, we're going to run getargs. And getargs is not pure, right? It doesn't always mean the same thing because people can pass in different arguments. So it's a thing you have to run. So it should be like an IO action that returns a string or list of strings. I don't know. Maybe someone passes in more than one string to the command. So it should pass in a list of strings. We can probably test that. Let's run some other function. Let's call this greet, and it'll take the name. We have to write this greet function. Actually, let's just try running it now. Let's see what that does. Hopefully it'll explode. And it does. So you might think that working with a strict compiler is slower than writing in Bash, but do you really think fighting with a compiler that tells you what the problem is harder than fighting with Bash that doesn't tell you what the problem is? Maybe you get a seg fault, maybe it just, I don't know, spins its wheels and makes the room a bit warmer. I think this is faster, and through experience, my experience at least, this is always faster than fighting with Bash and with, like, you know, incorrect line endings or some bullshit like that. So we haven't got the variable, well, we haven't got getargs. I believe that is in the system environment package. Is it? It is. So that problem went away. And now we don't have the greet function because we haven't written it yet. And isn't that nice? It already gave us the type signature. Do you see that? Because we used this function, getargs. It knows that getargs gives us, runs something and gives us a list of strings rather than just one string. That's why it's put it there. So it's told us what we need to do next. That's really, really cool. So we can write this function, greet, and we know that it takes a list of strings and does some action and doesn't return anything. Greet takes some arguments. But I think for the purposes of this script, we only care about the first argument somebody passes in. Let's not make it too complicated, right? We can say, hello, someone's name, rather than lots of other arguments. So we're going to destructure this list of things and just take the first one. That syntax is probably familiar to some people. This is like the head of this list, and then the next bit is the rest of the list. And we're just putting an underscore there because we don't care about the rest of the list. We just want the first one. And now, because we've taken the first thing in that list of things, it's no longer really args, it's the name we pass in. So we'll call it name. And then we can say something like, or we can do something like print hello, the name of the person, like that. This
Use the dollar to make it more like Bash-like. Yeah?
I use the dollar to make more money. No, okay, so this dollar, which you'll see in Haskell a lot, is it just means evaluate the stuff to the right of this first. So I could also have said this.
Now it's correct.
Now it's yeah, make less money though. Okay, this should fail, but I won't tell you why. So without passing in any arguments, this would be an incorrect program, right? It wouldn't. This is not what we want to do. And it's told us that the pattern match in that function is non-exhaustive, right? So we've only handled the case where someone's passed in something. So let's handle the any other case by just saying, let's say, name not provided. If we run this again, it says name not provided. Make sense? And then if we run it with some argument, let's say we want to say hello to the lovely Maya who runs this thing. Hello, Maya. Really simple, right? Now, this seems sort of pointless. You wouldn't normally spend your day writing functions to say hello to Maya. But we take simple examples so we can just talk about stuff clearly, right? You would extrapolate what you learn and then make bigger things with it.
Should I say something now or no?
Have I spelled your name wrong?
No.
It'd be really embarrassing if I spelled your name wrong. Only 4 letters and I still screw it up.
Perfect.
Yeah, type systems can't help you with spelling. That's probably enough with that example. So I'll throw it away. And I'll just show you an example that I've actually used before. It's a scraper. And the reason why I would have picked Haskell for this rather than Bash is because I need some libraries to do the web scraping for me, because I don't know if there's any web scraping libraries in Bash, probably not.
There's links probably. You can use it.
You could. I'll leave it at that. You could. I mentioned earlier that you can write these intro comments that Stack needs in a couple of different ways. So this is the sort of longer form multi-line format, which is nice because I've said I need the scalpel package for scraping, the ASON package, which is a JSON library, and the text package because one of Haskell's warts, I guess, really is that strings are represented in a few different ways. Like the normal string type is a list of characters, which is why we could do list operations in that last script. But you don't always want to use strings because they're very slow. You want to use something like text, which is very quick. That would also explain this language pragma, which just about everybody uses all the time in Haskell. And that means that I can do something like this, and it can be a string, or it can also be a text. I'm really bad at typing. Or it could be a byte string, or it can be any one of the different ways to represent strings. But you don't have to, it's a bit cleaner that way.
Okay, so that Haskell string, is it just like a linked list of characters?
Yes.
Okay.
That is supposedly why it's so slow. I don't know anything about computer science, so I can't tell you why it's slow, but it is.
It's much more memory because it's represented as a list.
Takes much more memory because it's represented as a list. Was that right? Okay, I'll skip down to the. Oh, this is way too big. How do I make it smaller? Was it this? Oh, it was. Okay. My Haskell code is like really gross. I sort of stopped caring a couple of years ago. I just gave up on life, and now I write horrible code, but it works, and I sleep better at night for it. So again, I have some main function. Just all main functions look like this. They have some, they run some I/O thing, and they don't return anything. 4M is like a loop. People will tell you that Haskell doesn't have loops, but for all intents and purposes, it's a loop. I'm doing something 83 times. Is that 82 times? I don't know. But from the numbers 1 to 83, do all this stuff. In this case, 83 is the number of sort of results pages in this company's database of data that I'm stealing contact details from. I wasn't lying before. So it does some scraping. You can see I've used this arrow because it's like it runs an IO. Yeah.
Is Ampersand, is there an Ampersand missing before results per page? After show I?
Where are we looking? I had a laser pointer, but the damn Swedish stole it.
The show I, yes, and then you have got results per page, next parameter without
This is
Ampersand.
part of the URL.
Oh yeah. Yeah, maybe it's broken. Oh. But when I run it, it works. Magic.
I mean, why shouldn't it? What was the problem?
Because when you URL encode parameters in a query string, each key and value should be separated with an ampersand. Because it's like key equals value and key equals value and you chain them along like that. And I also don't see the ampersand there, so that should be broken, but it's not broken, so maybe just the internet's broken. In a good way, in my case. Yeah, so M details links, in this case is short for maybe details links, because maybe I'll get my details links and maybe I won't. Scrape URL is some like monadic thing in that it runs an action across the network, right? Because it's scraping the internet. The internet can change at any time, so it's not a pure function because it depends when you scrape. Results could be different. So it does some scraping, and then we sort of do some more computations based on the result of that first scrape. Did we get a result or did we not? If we didn't, we skip down here and just print out, well, we couldn't find any detail links. So probably some of the scraping logic is incorrect. Or the page is down.
You should have used monad transformer with code.
I certainly should have, but as I said, this is very much throwaway code and I'm very lousy. But this still works really well for me. So here, handling the just case, let's say I do get a details links page. I don't remember what that was exactly. It's not really important. But I do another scrape. I scrape like the page from this website. And if I get one of those, then there are functions up here somewhere that sort of deconstruct the HTML on this page and take parts from each of the fields and create a company object, because my business sells company data. I scrape the fields from the page, create an object, and then serialize it to JSON. And if it's done correctly, it should. Do I have internet? Do I have internet? There you go, I'm scraping in real time. And normally I would run this on some server somewhere and let it run overnight and just give me all the data in the morning. A really nice thing about this is that I wrote this on a Mac, but normally if you write a Haskell program or any compiled program on a Mac, you can't then run it on Linux, right? But what I do is I buy a server or rent a server, put stack on that, and then copy this file over there and then run it over there. Of course, I would save the results of this. I already have this data, so I don't need to steal it anymore. Maybe I'm breaking some law, I don't know. Who cares? But that's all I got. Are there any questions?
Why not C? Python. Why not Python?
Where's my wallet? That's why not. And that's why not. I got to do other stuff. This is an optimization of my time, because there are many ways to do things, but this is the easiest way for me.
Because what I've seen is that you are using like monadic types for all functions anyway, so it's like you're defining procedures. It's really pretty much the same as if you were doing it in Python or any other imperative language.
I mean, for me, I've been trying to learn C, and it's very, very interesting. But it's really easy to screw up too. I've at least read from more hardened C developers that C is an excellent foot gun. and I still have all of my toes because of this. And again, really I'm optimizing for my time and my hours of sleep at night. I'd like to just write my thing and then forget about it and move on. Yeah?
Would you endorse the same approach using Haskell for some, for example, text or file system operations? Are there any Haskell libraries that will help you to make such scripts be better than in Bash? Because usually when I was reading Bash scripts, it was something about file system, about manipulating files, finding something in files in a local file systems, not copying internally.
I mean,
Is Haskell suitable for this? For file system operations and so on?
Well, it really depends on the context. I know that's a bit of a cop-out answer, that it depends. I can tell you that recently I wanted to build a static site generator, but it had to be really, really fast. Bash wouldn't really cut it for me. I don't remember why, but I tried it in Haskell, and I wanted to make like 4 million pages as quickly as possible. That's like a big load of directories. If you stick 4 million files in a directory in your file system, something's going to screw up. I mean, Unix sort of isn't built to work that way. Just things just start to fall apart doing that. But what I did do was I did most of the pure transformations of CSV data into web pages in Haskell, because that was easy to do. If there's going to be a photo, I'll put this down. Yeah, so all the pure stuff, all the high-level stuff was in Haskell, and then when I needed like a lot of speed, I wrote Inline C. And there is a package for that called Inline C. It's not a foreign function interface thing. You can just write C and it ends up being Haskell. And that was super fast. But I'm not really a C developer. I just sort of made that work. So I guess yes is the answer to that question. I don't see why not. It depends.
Could you tell what orders of magnitude was the speed up between Haskell and C, Inline C?
Oh, well, I did, I think, like 100,000 pages, went from a couple hours to a few minutes. But it really depends on data structures in Haskell. I forgot how important that is. Like, Haskell is so high level, and I often think of things in terms of their, I don't want to say mathematical value because I'm not a maths guy. But if I have, okay, I'll give you an example. I wanted to do in my main project this like list intersection of two huge lists. One was like 60,000 elements, one was 800,000 elements. And running list intersection with both those lists gave the right result, but it performed terribly. I needed to pay closer attention to the fact that they're both sets of things rather than lists. So you still have to be specific about a data structure if you want good performance with something. But that was really sort of context specific, right? So maybe not using C is fine in your case. It depends on the work you're doing. Any other questions? Yeah.
Is this way of scripting in Haskell becoming, say, like the default way to build Haskell projects? Or I mean, like open source? Is it popular to do this way in Stack scripting?
It's as popular as Haskell is, let's say. So popularity is so relative.
Yeah, I mean, do people use this actually for building Haskell projects?
Yes. And I do genuinely use this all the time for my business as well, and for my day job, because it's really saved me a lot of time. Any more questions? Is anyone going to go and do this? One person. One very enthusiastic. 3 people. Good. I'm waiting for the rest of you. I've got time. Not a lot of time.
Maybe one question.
Yeah.
Have you tried cabal or end? Can you compare it to stack?
Are you aware of the sort of holy war going on right now between cabal people and stack people? Okay. I try and stay out of it because I don't care for drama. But as I understand it, Stack uses Cabal, the library, under the hood to do stuff, because it still works with Cabal files in a project. I haven't used Cabal install, because there's Cabal the library and there's Cabal install, the build tool. I haven't used that directly in I don't know how long, but a long time. So I couldn't advocate for it either way. I couldn't say it's good or bad, I don't know. I just use Stack and it works for me. Any more questions? Don't be shy. Is that it? I think that's it. Okay, thanks very much.